Is the Big Bang really dead this time? Eric Lerner, famous for his decades-long crusade against cosmology, claims he's found the final nail in the Big Bang's coffin. His supposed proof? Problems with the element lithium. He's calling it the smoking gun that saves us from the Dracula-like Big Bang. But is he right? Or is this just another conspiracy meltdown? Stick around, because today we're diving deep into the science of Big Bang nucleosynthesis and see if it's really true what he claims, that the Big Bang never happened. Gather around, science fans and skeptics alike, because it's time for another encounter with our good old friend, Eric Lerner. You remember Eric from 2023's The Big Bang Never Happened. And this time it's courtesy of another final nail in the coffin, according to Eric, that will save us from the Dracula-like Big Bang and usher in a new realm of plasma cosmology. And if that weren't enough, stay tuned to the end, where Eric will pitch you to support his plasma fusion fantasies. Last time we encountered Eric, he was waxing rhapsodically about the early galaxy problem, which turned out not to be a problem at all, except for Eric Lerner's credibility. Today we're going to a recent video where he got tons of coverage, including people that seem to believe that there's a conspiracy, a cabal of Big Bang proponents, sponsored maybe by NASA, to bring the whole framework of the Big Bang crashing down in 2024. And he says it did. Spoiler alert, it did nothing of the sort. Eric's been going on about the Big Bang's non-existence since the early 1990s. It's been over 30 years since Eric published his first book, The Big Bang Never Happened. It's also his last book, but that doesn't stop him. No matter when new data come in or he is confronted with challenges from experts, his recent claim is that we've all been too busy doing actual science to notice all the great breakthroughs in plasma physics that led to 2024 being the year the Big Bang was put to rest. 2024 was nothing of the sort. It just marks another theory to supplant the Big Bang. For what reason, I'm not quite sure, other than to motivate plasma physics, which he will conveniently pitch you for at the end of each video to support. And he's received several $1 million for this project. It's no small affair. People are supporting his dreams of a plasma physics paradise brought on by his reactor in Pennsylvania somewhere. Now, it's fine to challenge the Big Bang, and no theory is perfect. In fact, he calls it a hypothesis. I don't actually have a problem with that. In fact, most people say theory is as if it's only your theory or my theory, like I've got a theory about the Kennedy assassination. But this time it involves not galaxies, not even the CMB, or baryon acoustic oscillations of the Sunyaev-Zildovich effect. No, this time it has to do with the abundance of light elements. Now, this is a crucial pillar of the Big Bang theory itself. Big Bang nucleosynthesis indeed predicts the abundance of the lightest elements on the periodic table, the ones that are later found to be the ingredients of stars, and the future byproducts of which become the heavier elements when stars explode and populate the interstellar medium with their heavier elements. The focus of Mr. Lerner's attack in this video has to do with the abundance of one element alone. He seems to have given up on the fact that the abundance of many of the isotopes of helium and hydrogen match beautifully with the Big Bang prediction. Of course, he locks on to one of the inconsistencies, comes up with a proposal for a better model. Of course, it's his model, where all the helium in the universe is produced in stars, even though there's been evidence against that since Hoyle proposed it in the 1960s. You'd think that he would at least pay homage to the greats of astrophysics who came before him and cite their results that showed that you couldn't make enough helium from stars. Of course, stars make helium. The word helium comes from Helios, the sun god, and it was discovered on the sun. NASA went there at night and discovered it. No, we've discovered it spectroscopically. We know that it does produce helium. Now, the amount of helium cannot be produced in sufficient quantities to avoid producing too many heavier elements, and he has no way of explaining that. Instead, he talks about the production of the lighter elements coming from a very arcane process, which is known to happen in very minuscule amounts and can't produce the observed amount of deuterium that I discussed in my video, The Most Expensive Water in the World, where I discussed heavy water and actually did a taste test of heavy water versus that pricey Fiji water and even a $50 bottle of water called Berg. Measurements of ancient low metallicity stars do show a shortfall of lithium compared to, say, naive estimates of what astrophysicists have been predicting for many years. The codes that predict this have been tested for over 60 years. The mismatch is real, but guess what? Every single hypothesis has mismatches, has problems that don't necessarily nuke them. The absence of a missing link does not invalidate the theory of evolution to people that are sane. It just means that the story of lithium is more complicated than astrophysicists had assumed. That's part of the great privilege of being a scientist, is that you get to honestly confront data and hopefully agree when you are wrong and not continue kicking a dead horse that died early on in the 1960s. Now, recent peer-reviewed studies, including Fields 2011, Seibert et al. 2016, they examined possible reasons for the lithium value that's measured. And of course, we can't be certain that any prediction will match any observation for a variety of reasons. The theoretical prediction can have uncertainties in it, the ingredients that go into it. All theories have calibrations of their own, and then the measurements can be quite hard as well. There can also be production and even exotic physics at play, but it marks no such thing as a death blow or a coffin nail into the Big Bang.
Death blow. When someone tries to blow you up, not because of who you are, but because of different reasons altogether.
Even Lerner's explanation fails to produce the amount of lithium that's observed. It just does so with about 15% more closely to the Big Bang prediction. Lerner lumps this into his Big Bang is done playlist, which he's been on rotation for the last 35 years, ignoring the fact that mainstream astrophysicists have known about this problem, talk openly about it, and in fact are encouraged to make in-depth measurements of these discrepancies. It's part of the fun of being a scientist. It's not some hush-hush conspiracy, a cabal, as he has asserted about other active areas of scientific research as a whole. He'll claim that he's being censored. He'll compare himself to Bruno and to Galileo. In the recent video, which is now coming up 80,000 views, some with very depressing comments, but this is on a measurement of what's called the Small Magellanic Cloud, a satellite galaxy of the Milky Way, that shows lithium is 4 times less than expected. Now cue his triumphant fanfare. The Big Bang is dead. One measurement out of the thousands of supporting data points, literally tens of thousands of data points that agree with the Big Bang, he has found one which is discrepant at a significant level, but for which involves a lot of unknown astrophysics, evolution of galaxies, and even chemistry. So now we're into the process of chemistry and the processes within stars that vary across systems, including across our own Milky Way and its satellites, the large and small Magellanic Clouds. So you expect a variation in the abundance of lithium that can deviate from the most simple predictions of the Big Bang model. It's not a gotcha. It's a clue about how we need to refine our understanding of how galaxies form and evolve. And this we talked about with Alison Kirkpatrick and other astrophysicists. And I mentioned this on the Joe Rogan podcast episode 2023, in 2023, when I got to have a chat about this proposal that had been going around in 2022 and 2023 that the Big Bang never happened, based upon faulty interpretations of mainstream astrophysics, including new data from the James Webb Space Telescope. Now, Lerner insists that lithium can only be added over time, not destroyed. Sorry, but stars are called furnaces for a reason. Nucleosynthesis builds heavier elements from lighter elements, and the process that is more complicated than the Big Bang is called stellar nucleosynthesis. And models of stellar nucleosynthesis show that lithium is easily destroyed in hot stellar interiors. So we need a much larger survey to be conclusive. Now, when stars produce heavier elements, the convective processes can actually obscure and bring and circulate that lithium down to regions that are deeper in the core, where it is burned more efficiently and is therefore depopulated relative to what you'd expect. That's astronomy 101. Instead, he's using a discrepancy from one paper, again, taking it out of context, as he did with the rotation structure of early galaxies in the James Webb Space Telescope data, as he did 30 years earlier in the Hubble Deep Field measurement. This is really beating a dead horse. Now, he fails to discuss how other processes can reduce lithium in older stars. His quick dismissal is basically him asserting that he can ignore half a century of the most prominent astrophysicists in history and their calculations and their research. So let's go through one by one Eric Lerner's claims and show how they're decidedly misplaced, inaccurate, and altogether unscientific. But before we do that, let's do a brief overview of what Big Bang nucleosynthesis is and why it's so important to the Big Bang model. Big Bang nucleosynthesis is the observation that the lightest elements on the periodic table were formed by nuclear fusion reactions, such as those shown here. There's only a handful of them, but with one exception and one alone, they match beautifully between the observations that we see and the predictions of the model. These incredibly light elements were produced during a time period shorter than the TV show The Big Bang Theory, but they made the lightest elements on the periodic table, including isotopes, deuterium, helium-3, tritium, helium-4, and trace amounts of lithium and beryllium. And we'll see why that's so important and why the observations are not nearly as devastating as you'll hear Eric Lerner claim them to be. They depend primarily on one parameter, what's called the baryon to photon ratio, symbolized by eta. It's stunning that from such a simple underlying theory with just one free parameter, the abundances for these half dozen or more primordial elements and their isotopes can be predicted almost exactly. The primordial lithium problem is the name that cosmologists have given to the deficit between what's observed and what's predicted for one of the isotopes of lithium, lithium-7, the one isotope with 4 neutrons. On the other hand, not looking at the early universe, looking at the late universe, looking at old and metal-poor stars, we see that the amount of lithium is about 1/6 of a billion, so 1.6 times 10 to the minus 10, whereas the abundance from the Big Bang Theory predicts a factor of about 2 to 5 lower than that. Now, it's real, and that's an unresolved problem, but that's table stakes. Every single model that's been postulated by any human will always have 1 or 2 so-called missing aspects of it, or unresolved aspects. And that's good, because that gives us a reason to study and go deeper. But it's much more complex to analyze the properties of stars, both their observed properties from spectroscopy, as we'll cover, and from the predictions based on stellar model interior, because those involve very complex physics and even chemistry, mixing convection, surface depletion, and many other phenomena. Shown here is the slide that really matters. Deuterium and helium-4 match perfectly with what the Big Bang Theory predicts. There's no way to explain that in Eric Lerner's favorite tired light model. We'll get to that criticism of his proposed alternative later. And this is true even after decades of data. These aren't back of the envelope or, bottom of the napkin type calculations. They're excruciatingly precisely measured and calculated abundances. Lithium, yes, it is still a problem. It's off by about 2.5 sigma, which is very common. There's an old joke. If you measure something at 2.5 sigma, it won't even get published, let alone the napkin. And nobody would ever claim that this is a death knell for any theory, let alone a theory as well-founded as the Big Bang Theory. So I showed the reaction flow chart. It's, again, remarkable that by measuring certain properties, cross-sections, half-lives, and things like that, of different isotopes on Earth in laboratory measurements, we can predict exactly what would have been seen 13.8 billion years ago, when the universe was less than 20 minutes old. These reaction networks are incredibly well studied. We understand them. There are no free parameters that are tuned to force these calculations to work. And yet all of these isotopes seem to agree, with one exception, and that's true. I'm not going to ignore and sweep under the rug, as Lerner does with literally tens of thousands of data points. Don't be manipulated by his charming rhetoric. It's actually tens of thousands of independent data points substantiate the veracity of the Big Bang model. And this one discrepant measurement, but again, discrepant only at a 2.5 sigma level, is the one that he's choosing to harp on. And then he amplifies that, as we'll see, in a rather disingenuous attempt to sway you, the possibly unsuspecting viewer, although if you're watching my channels, you are certainly among the most brilliant in the known multiverse. Now, he claims that this discrepancy falsifies the Big Bang, which nothing could be further from the truth. And stay tuned till later, because I'm going to go through his claimed model and solution and show that it's thoroughly considered and rejected for many, many years. What Lerner does is like saying general relativity is wrong because Mercury's orbit was once off by 43 arc seconds per century. Science doesn't work that way, Eric. I know you didn't go to graduate school, and I'm not faulting you too much. But the fact is, you're misrepresenting a theory because of one anomaly, one discrepancy. And again, there's thousands of other, not just a handful, not just 1 or 2. There's thousands of other lines of evidence that strongly confirm it. More than ever, yes, there'll always be unknown and undetermined parameters within a model. That's basic science. I'm sorry you don't grasp that. Deuterium and helium-4 agree exquisitely well with the Big Bang nucleosynthesis theoretical predictions within observational error. So much so that there's no free parameters. And we can compare based on the predictions with the cosmic microwave background measurements. Shown here, I show this Planck. This is from a compilation from an incredible website that goes through these calculations. You see how much detail that is, and I leave the link in the website. Thank you to the author of this website. It goes through these calculations. You could download it and run it on your own computer. These theoretical predictions and comparisons with observational data are just exquisite and make me so proud to be in a community of actual scholars who care about the details and the facts. The lithium problem problem is a challenge. It's not a death sentence or a nail in the coffin in Eric's misleading presentation. But that's par for the course for people like him, and you'll see later on what his motivations may just be. So it's a puzzling isotope. We'll study it. My theoretical friends will continue to make predictions and refine them based on new observations. So lithium between the stars, nails in the Big Bang coffin. First of all, the incredible emphasis on a single observation of a single star in a single dwarf galaxy, which is the Small Magellanic Cloud, would never be enough. Even if it was discrepant by 100 sigma, it would never be enough to on its own refute the Big Bang. That is point number one, and you must understand that. But let's go through systematically his anti-Big Bang claims, and the reason that he may be doing it I'll reveal to you at the end, as he does at the end of his very thrilling and widely viewed video. He claims that the Big Bang has been invalidated by just this measurement of this one star, and that many contradictions will soon follow. I want to go through one by one what he's actually doing here. He's employing what's known as rhetorical overreach, with no qualifying statements, very few citations, and zero methodological transparency. Now, I know if I make fun of him for not putting error bars on the data points shown in his plots where he makes these seemingly out of Microsoft Excel, I'll get criticism in the comments. Okay, why are you being so mean to him, Keating? He's just doing his best. You just have this at stake because you care so much about NASA and Big Bang and Big Bang. No, that's not the way science works. The invalidation must be quantitative, peer-reviewed, and replicable, none of which applies to what Eric's done. In fact, he claims the reason he can't get things published is because there's a cartel, a conspiracy, just like against Bruno and Galileo. Now, he frames this one discrepant data point, which I'll show, as a total falsification of an entire model that's based on tens of thousands of observed data points. He claims the observed ratio of lithium-7 to hydrogen and low metallicity stars is 4 to 20 times below the Big Bang predictions. Again, you can say it's 100 times below, but if you don't quote the error bars on it, as he never shows the error bars on his predictions, nor on the data that's shown here, it turns out to be a very, very small discrepancy in terms of standard deviations. Yes, it sounds like a lot, 1 in 300 as he mentions, but really the probability to exceed in the null hypothesis that the Big Bang never happened is much, much lower. We don't have any reason to believe that the Big Bang never happened, certainly not based on this one data set. But even restricting ourselves to just Big Bang nucleosynthesis, theory versus observation, the abundance of the isotopes of helium, the abundances of deuterium, and of other isotopes agree extremely well with both the theoretical predictions and the cosmic microwave background derived baryon density. And all these depend on the baryon to photon ratio, as I displayed earlier. Now, in contrast, the deficit can be explained in the amount of lithium compared to what theory predicts, based on the fact that the processes in stars and even the systematic errors of making a theoretical prediction and making the observations is incredibly difficult. So it's a known anomaly, but it can never overturn Big Bang nucleosynthesis, let alone overturn all of the Big Bang theory. There are many other explanations for this phenomena of low abundances of lithium in stars, such as surface depletion in stellar atmospheres. There's all sorts of really interesting atmospheric effects, diffusion, rotation-induced mixing. Stars are active. They have spots, they breathe, they expand, they pulsate, they vary, and we don't understand from first principles even how our sun was formed or how it's even doing what it's doing from, as I said, from first principles line of reasoning, but that doesn't invalidate the principles of fusion to understand how stars actually shine. This has been known since Hans Bethe and many, many other physicists for nearly 100 years now. Now, in practice, having some uncertainty is not to be ignored, but it doesn't dismiss a 50-year-old theory based on a single anomaly. And it is one anomaly. He's talking about the observations done by a team using a telescope in Chile of a single star, again, a single star in the Small Magellanic Cloud. He makes it out to say that it's true of every star in the Small Magellanic Cloud. That's actually absolutely false. We don't actually know. We know one line of sight for one particular star shown here, as the authors contend. They don't talk about this as being a death knell for the Big Bang Theory. And it's very reminiscent of his cherry picking of a title of a paper called Panic at the Disk. He spun that into a lot of attention for himself back in 2022, that there was somehow panic amongst astronomers and that the edifice of the Big Bang was falling down. Of course, no one's looked into his theory because it's so tenuously unpublished, unreplicatable. But again, you cannot take one line of sight, it's called cherry picking, and say that applies to not only every star in the Small Magellanic Cloud, but every star in the universe, because that's what you'd have to do to fully rule out the fact that we completely don't understand how lithium is produced. You'd also have to apply ionization correction factors, understand the ISM, the interstellar medium, around a distant star in another galaxy, and how so-called dust grain depletion effects may cause a reduction in the observed amount of lithium. In other words, it may be producing plenty of it, but we don't see it because of this observational gravitational suppression effect. He ignores all this, fine, no, pay no heed to actual data or how astrophysics is supposed to be done. Then he goes into his explanation of how cosmic rays could produce lithium. It sounds fanciful, you could make cosmic rays produce lithium. He then refutes himself because he shows that his mechanism doesn't account for the same amount either. It has a slightly smaller level of disagreement with the Big Bang model than do the current observations from the CMB, for example. He completely ignores earlier work as well, also in the Small Magellanic Cloud, with different objects and subjects, and that which showed that there's within 2 sigma, in other words, lower discrepancy of what the Big Bang predicts. No one would ever claim that they'd risk their career on a 2 or 3 sigma discrepancy. But he brings up an argument, so-called spallation argument. Now, cosmic ray spallation is well known. It's a natural process involving abundant particles of high energy called cosmic rays. But to Lerner, it's a magical lithium factory, creating lithium in spectacular abundances with a specific isotope ratio, so-called lithium-7 to lithium-6. Both lithium isotopes have a number of protons equal to 3. That's their chemical period in the periodic table, but they differ. One has 3 neutrons, one has 4, and this is crucial. So the ratio of lithium-7 to lithium-6 is predicted. So Big Bang by itself makes essentially no lithium-6 at all. This has been known for a long time. If Lerner were right, we'd see roughly equal amounts of these isotopes everywhere. But guess what? Meteorites, like this one that you'll get if you go to briankeating.com/list and join up my email list, have an isotope ratio of about 12 to 1. That means for every 12 atoms of lithium-7, we see 1 atom of lithium-6. Measurements in the interstellar medium show these ratios about 40 to 1. This tells us without doubt, unequivocally, that most lithium must have started with a source that had almost no lithium-6. Exactly what the Big Bang model predicts. Interstellar lithium can also be affected by gas-to-dust ratios, ionization corrections, and chemical evolution, all of which Eric conveniently skips because that would be devastating to his argument. But it sounds plausible to you the way that he describes it. He shows some data, he shows their actual publications by legitimate scientists, then he distorts, disrupts, and disputes what is actually claimed to be as evidence in the astrophysical community. Now, I'm sure if we asked him, where is this work, where is this result? Again, he finds a paper, this was from last year, he calls this the devastating nail in the coffin. Remember, this is the high stakes that we have to be reminded of. He's saying this is the death knell, this one observation of a single star in a single dwarf galaxy satellite of the Milky Way. It doesn't present anything new, no new calculations. Spallation, even if it occurs, would also overproduce beryllium and boron, which we don't see. So how do you explain that, Eric? You don't. You just ignore it, because that's what cherry pickers do. So this has been known for a long time. The spallation can be assumed to be a source. I'll put in the link below how researchers have long since dismissed the spallation as being the explanation for the plateau observed in lithium-7 and metal-poor stars. Now, modern simulations of galactic chemical evolution, the references below, Pranzos et al. 2012, show that primordial Big Bang nucleosynthesis must dominate early lithium-7 production. He claims that the Small Magellanic Cloud is only 1 in 300 compatible with the BBN, and therefore, he claims, he does a very simple calculation, divides 1 by 300, and says that BBN is therefore falsified at 99.7%. Now, that's completely flawed logic. But that's not a surprise, because he often cherry picks one outlier and ignores the global chi-squared from across multiple sources and multiple elements. So he's ignored the very high degree of compatibility between the Big Bang nucleosynthesis model, between the eta, the baryon to photon ratio, predicted for the other elements and matched nearly exactly. He doesn't compute a cumulative chi-squared from those. He doesn't go through and calculate it for deuterium and helium-4, and for that matter, for lithium-7. If he did, the global fit would strongly favor the Big Bang model with over 95% confidence. But this has been proved and shown, for example, in the Planck 2018 data release. There's a red flag here. Nowhere does Lerner show what his non-expanding model predicts for helium-3 or for helium-4. Any timeline for nucleosynthesis must be also compatible with the known lifetime of stars. How do you produce all this matter in a universe that's not expanding? And you have to get it by creating new matter, and overproduces elements like I mentioned earlier with boron, helium as well. This has been known since Hoyle in the early 1960s, and Hoyle was a good enough scientist that he realized this killed his current model, the quasi-steady state theory back then. Now, I never knew Hoyle, but I do know Jayant Narlikar. He's been on the show. It's not like I just throw out any person who tries to contradict the Big Bang model. I've had on many people that don't believe the Big Bang happened. That's fine. I'll continue to have them on, but they're doing the work. They're presenting the limitations of their model and how they could be wrong. Lerner never does that. He has motivated reasoning, and that motivation comes down to the almighty dollar. Here you'll see how he transitions so glibly from debunking all of cosmology to then pitching to his viewers to invest in his fusion company.
So if you want to contribute to that quest, please visit us at LPP Fusion. You can invest, you can donate, do what you can.
He says it has a $80+ million valuation, and he says there's no other alternative sources as far as his research shows, but based on the sloppy, shoddy way that he does research and cherry picks information, I'd be very reluctant to want to invest in him personally. This is not financial advice. But to go through a pitch at the end of a video with claiming that the Big Bang is wrong and then saying your new technology is going to revolutionize the energy industry and alleviate the need for fossil fuels is just ludicrous on its face. So I have a table here and showing the different tactics that he's employing, how he goes through cherry picking, selecting only lithium, ignoring the agreement on multiple elements like deuterium and helium. No quantitative modeling shown in this video, no equations, no curves, no statistical comparisons of his model or the actual agreement between the data that conveniently do not agree with his claim that the Big Bang never happened. His misuse of statistics, this claim of 1 in 300, probability without any context. He doesn't show any peer-reviewed citations for his alternative models. He doesn't link or cite any even preprints that he's working on that claim to produce things. In fact, to give him his due, he does admit that his method also doesn't produce enough of lithium. It's sort of self-refuting. He makes an emotional appeal based on his scientific narrative, and he presents a false dichotomy. He says that either the Big Bang nucleosynthesis model, and therefore Big Bang theory itself, is either perfect or it's totally false. That's called false dichotomy. Instead of dismissing the Big Bang, cosmologists treat the lithium problem as they should. It's a tension. It's one worth exploring. It's possibly due to unknown astrophysical systematics, either in the theoretical calculation in the Big Bang theory nucleophysics, the early universe, or in the observational data that we have. No observations are perfect. I know, it's very hard to do observations, and these observations shown in the Small Magellanic Cloud are beautiful, but they're only related to one star, and we need more information. There could also be new physics, and that would be the most interesting example. In other words, the Big Bang is true, but there could be some variation in some properties of the Big Bang at early or late times, depending on how we're looking at it, or how galaxies form and the chemical evolution thereof. It's not a reason to throw out a theory that explains so much. But wait, there's more. If you really want a clean test of a Big Bang nucleosynthesis model, look at deuterium. Unlike lithium, deuterium is only destroyed in stars, never created in significant amounts by them. And what do we find? The observed primordial abundance is exactly dead on, centered, agreed with the Big Bang nucleosynthesis prediction. In his video, he leaps to describe his non-expanding universe claim. That's right, the steady state model, the tired light model, the one that collides with every piece of evidence we have, the one that even his hero Tolman, who came up with the idea long ago, dismissed as being invalidated. And that was before the discovery of the cosmic microwave background radiation, which marked the watershed when cosmology became a precision science. So here are the key pieces of evidence that Lerner conveniently sidesteps. Number one, the cosmic microwave background. Now, I'm sure he'll say, Keating, that's the way that you butter the bread around the Keating household. And I've said that many times in jest. But going back to Kobe, WMAP, Planck, and all the modern measurements just recently released by the ACT team, the CMB is observed to have a perfect blackbody spectrum, with tiny anisotropies precisely matching the predictions of Big Bang cosmology. Yes, there are things we don't understand. There's unknown physics, as there was in the time of Isaac Newton, and even in the time of Einstein himself. There's always going to be new mysteries, and new data from more precise telescopes should overturn previously held beliefs. He also ignores primordial helium abundance, predicted as precise as possible to be about 24 to 25% by mass of the universe's energy and mass budget. And that's exactly what we see. We also see abundant evidence of the expansion of the universe. Multiple data sets that are completely independent. Supernova distance ladder, the baryon acoustic oscillations, the CMB, all indicate the universe is expanding. Yes, there's so-called differences, the Hubble tension between the rate of expansion at early times versus late times. That's to be expected when you're making measurements at the sub-percent level of precision. Meanwhile, there's no model that explains the tired light phenomena, and what you'd see in a tired light universe is completely contradictory to what we observe in telescopes. It doesn't predict the CMB. He has to sidestep all of these things, just to wave around. One piece of evidence, the puzzling lithium abundance measurement. And I'll have another channel that also throws in the lithium challenge alongside a commercial for a new skincare product. I'm serious. This is a much larger channel. Stay tuned for that takedown in an upcoming video. So we've seen the lithium problem is not a problem at all. Lithium is very hard to measure. The abundance relative to hydrogen is, fractions of a part in a billion. And measuring those things using stars and spectroscopy is notoriously hard, even if it's local in your own solar system, let alone if it's in another satellite galaxy like the Small Magellanic Cloud. This is not a problem. He's twisting the research intents, which is a measurement, to support and bolster his own failed model that the Big Bang never happened. Back in actual science land, researchers are still hard at work trying to understand the cross-sections and reaction rates and continuously trying to refine their nuclear physics predictions. There's another element, an isotope, that can be used to understand the so-called lithium problem, and that's beryllium. Beryllium also has an isotope with atomic mass 7, where you can collide that with a neutron and produce lithium-7 as well. We're also trying to understand better cosmic ray spallation, stellar yields, and mixing in their evolution. It's a very complicated thing. We also want to consider how dwarf galaxies like the SMC, the Small Magellanic Cloud, might have unusual star formation histories. These could all affect the abundance ratio of lithium-7 to lithium-6, but he ignores all of that because he found something that seems to cast doubt upon the standard model of cosmology. So if stars formed under different conditions, they could easily shift how much lithium remains in their local interstellar medium and how it got cycled. This material, older than our sun, it came from a pre-existing star that was in our solar vicinity, and another solar system would not be expected to have the same isotope ratios depending on its past history. And that's why we can use meteorites and other things to better understand the so-called lithium problem. But it's not a sign that the cosmological model is dead. And as long as he'll do that, I'll keep on producing these brutal takedowns. So if you want to see real data, go look at the Planck collaboration 2020 results, or the recent results from the Atacama Cosmology Telescope. They lay out the evidence for an expanding universe in such airtight, unequivocal terms, with such exquisite precision, you will not doubt for a second. But of course that's hard to do, and Eric knows that you're not going to likely do that. But if you do that, you'll avoid the cosmic meltdown. But I can't end this video without analyzing what's become a trope for so-called Big Bang deniers like Eric. I started the video, liar, liar, Big Bang denier, but there's also flat Earth deniers, Apollo moon landing deniers, evolution deniers, and they're all substantiated by the same types of dangerous misinformation, and it all follows a predictable pattern. First, cherry pick one out of perhaps hundreds of solved problems, cherry pick one unsolved question, or one question where there's large uncertainties, as it is with the lithium problem. Ignore overwhelming evidence supporting the model, and key in and hype up your audience to key in as well through your misrepresentation of the nature of how science progresses. Then implant doubt in the theory where there is none. If you think that flat earthers are a joke, there's no reason to think that the Big Bang deniers are also not a joke. Their arguments are about on the same level, just that we can't go back in time and actually witness the Big Bang as we can here. But of course, most flat earthers are not trying to sell you some skincare. They're logically flawed because they don't invalidate the established models. What they're trying to do is appeal to emotion. But for sure, it makes for entertaining clickbait and a chance to sell your fusion dreams. I want to leave you with this final thought. Would you reject evolution because we haven't found every single fossil in the history of the Earth's past? Would you reject germ theory because we don't understand fully the properties of every single virus known to exist? Would you reject gravity simply because we don't have a quantum understanding of gravity, and it complicates our understanding of gravity in extreme circumstances? Encounter that when we encounter our next debunking video, also involving lithium and also trying to sell you dreams, not of fusion perhaps, but of delightful skincare routine. Gotta know your audience, I guess. So some people need lithium to balance their bipolar disorder. Some need it to overturn the Big Bang. Okay, so I hope you enjoyed this deep dive. This is just one of many videos that I've done about this character, Eric Lerner. I know many people want me to debate him. Maybe I should. Leave a comment down below. Should I debate Eric Lerner? It'll be good for his CV or mine. Leave a comment. And if you'd like to see a previous debunking with my colleague Alison Kirkpatrick, click here.